Welcome all to lecture 16. So, in today's lecture we are going to discuss about geophysical investigations in particularly related to the offshore environment. So, if you recall whatever topics we had covered in the last class, we started with the introduction of offshore environment, because till the last class till lecture 14 we are precisely discussing about different classes of investigation, different phases of investigation, then different methods, whether it is geotechnical or geophysical methods. Interpretation wise, we were discussing more precisely related to onshore structure, the kind of structure we are constructing or targeting, whether it is for new structure, whether it is for adjoining structure, whether it is the suitability for construction material, mostly related to land masses. In the last class we also highlighted, because of several reasons, people are also moving offshore, particularly related to as we see related to whenever we see whenever we consider earth to be very dynamic, starting with the magnetic poles, then reversal of magnetic field in the geological time scale, then as we go onto the ground surface and deeper than that, we see that most of the processes are getting governed by continental drift, because that is we can say like that is overall governing the configuration of land masses, configuration of oceans, and the process happening at the interface of the land masses as well as the ocean. More precisely to be said, like the continental margin, continental shelf, ridges, continental rise, abyssal plain, whatever we had discussed in last classes, as a result of which sometimes you are having gradual variation between the adjacent continent as well as the oceanic plate. Sometimes it is too steep, depending upon what are the processes governing the at that interface, then the relative thickness of continental plate as well as oceanic plate, so on and so forth. In the last class we also discussed particularly the continental margin, which has been understood as the possible locations for oil and gas depositions, which particularly the agency which are responsible or interested in exploration, its main target for detailed investigations. So, one is this thing, like whenever we are interested to go for oil and petroleum exploration, we can go for detailed investigation, which is classified under offshore structures or offshore investigation. In addition to oil and gas exploration, in the last few decades, other useful other applications of offshore environment had also come into picture, whether it is related to transmission cables laying on the sea floor, or maybe long term storage for carbon dioxide gases, or similarly as erection of wind turbines offshore, because there will be continuous supply of winds and relative fluctuations will also be less, and in comparison to land mass, it will be far easier as far as the maintenance goes if you are constructing or erecting wind turbines offshore. Similarly, we also discussed, like offshore, lot of time people are going to in order to set up some heavy industries. Whenever we are creating some artificial islands for tourism, for colonization purposes, even as for offshore airports, even for the case of tunnels, bridges, lot of investigations offshore are happening. And then support ports, as I mentioned earlier, in order to minimize the traffic movement near the actual coastal line. So, the bigger container traffic can go to those support ports, and from there to the actual coastal line, the material can be imported through small vessels. So, accordingly the depth and other things can be controlled or decided. We also discussed what are the different materials, starting with sediment characteristics, depending upon the time required or given for the sediment to get deposited at a particular location. Some might be normally consolidated. On the contrary, you can have over consolidated sediments, so on and so forth. So, that will govern how the sediments are going to respond once you lay particular foundation, whether it is for exploration purpose, whether it is as communication cables, whether it is anchored structures, how it is going to respond. We also discuss once the calcium carbonate, which is present in abundance particularly in marine environment, once that gets precipitate, it acts as a binding material and binds the sediment which is available at the sea floor. So, depending upon the binding characteristics of the calcite, the binding characteristics of binded material or the end product may also vary. Then we also discuss SAR gas fields, which are particularly the deposits of nitrates, whether in form of small bubbles in pore fluid or between the layers, which can cause two problems. One is like explosion, second thing may be because these are poisonous, that can lead to even deaths. So, we have to be prepared for that. Then we also discuss about hard seabeds, how they can pose more problem in terms of resistance offered to pile driving. Similarly, whenever you are trying to get more and more resistance as shaft resistance from hard rock or hard bed, it will be difficult in comparison to a relatively tougher material. We also discuss what are sand dunes and how they can control or govern the serviceability or design life of the structure, whether in terms of settlement, whether in terms of differential settlement or any other kinds of failures. We also discuss potential differences between an onshore structure or an offshore structure and what are the possible geohazards. So, this why I am going through in this much detail, because offshore, as we know, like many of the basic courses, this offshore structure is not covered. So, whatever I had discussed in last class, I have just given you a brief revision of the topics which we had covered. Now, before going to further into detail for geophysical investigation, certain more points are there. We discuss about sea floor material, we discuss what are the problems it can cause. So, there are maps particularly which are indicating the thickness of sediments across the globe, whether it is land mass, whether it is ocean. So, those maps particularly referring to the National Geophysical Data Center, that is NGDC under United States Geological Survey. So, one can refer to those maps and that will give you an idea about like your possible location, that continental margin where you are going for detailed exploration, what is the overall depth of sediments as per those maps. So, one can go about this, then depending upon the depth of the sediments, you can get an idea about what method is best suitable for the kind of material, the kind of depth, and that will also give you an indication like what is the depth you are interested to explore for based on detailed investigation. Usually sediments are available in more thickness near the land mass in comparison to the ridges which are available within the sea. However, there are other locations also where you do not find almost any sediments, because whatever sediment was deposited in a small time get washed away by high water currents. So, there can be possibility within sea itself where you have very thick sediments, as I mentioned, like the continental margin which will be adjacent to your actual land mass. So, you can expect relatively larger thicknesses. In comparison, if you go to ridges, you will have lesser thicknesses. Then where the water currents are higher, particularly in intermediate depth, you can have relatively no sediment deposits at certain location. We know like land mass, the entire land mass which is globally available, though it is only 20% of total oceanic surface. However, the land mass containing the sediment, 75% of that sediment comes from the marine origin. So, the sediment which is deposited, whichever we see onshore, almost 75% of that sediment is coming based on the marine deposits or marine origin. Similarly, the sediments available on the sea floor itself can be categorized broadly into two categories. One is known as terrigenous sediments, which are more precisely called as those sediments which are transported from actual land mass to the ocean environment by means of different weathering agency, whether it can be glacier, it can be because of river, it can be because of wind, it can be because of gravity. So, those are called as terrigenous sediments. Then you have pelagic sediments, which are particularly the sediment which are of marine origin, but get deposited as it settled, as it has undergone the process of settlement through soil column. So, precisely you may have terrigenous sediments, or you can have pelagic sediments which are available on sea floor. Then so we know like sediments, why the sediments are there, because either it has been settled because of the stresses offered by the water column or by different weathering agency which brought the sediment into its in situ condition and where those get settled. Now we know the sediments are there, we know below the sediments or even sometime within the sediment there are possible location where you can have deposits of your interest, maybe gas and oil deposits which you are interested to explore, and so that you can bring out onto the surface for different purposes. Secondly, for to use at suitable construction material or in order to even create an artificial island or foundation for wind turbines, you have to go for detailed investigation. So just like when we were going for detailed site investigation onshore, there are certain objectives when we go for site investigation offshore also. So these particularly the objectives, the first one is to provide sufficient information which is required so that you can select a particular kind of foundation, how the foundation design will be governed, and once the designing is over, how the foundation is actually going to be laid, or how you are going to lay the particular foundation in its in situ condition. So everywhere the information whatever you are gathering for your offshore investigation will play a role. It is related to selection of foundation, it is related to design of foundation, it is related to actual execution or laying of the foundation in its actual condition. Second thing, if you are going for anchored kind of structure, then what are the stresses which are going to control the design of the anchor, the behavior of the anchor, the strength of the anchor will also get input from your site investigation of offshore structure. Third thing, if you are designing some kind of connection, particularly for pipelines or even for communication cables, so this site investigation is going to give you some input like what are the expected level of movement the particular connection has to withstand, otherwise there will be a failure in the actual structure. So that is another objective, particularly when are you going for offshore, which was not there in onshore repeatedly, that is I am telling. Then to quantify possible cyclic loading, as I mentioned last time, in comparison to onshore structure, offshore structure are dominated by cyclic loading, whether it is because of ice, because of water currents, whether because of seasonal variation as well, or maybe due to the gravitational pull by maybe moon or sun, that will again lead to change in your water column depth as well as result in cyclic loading. So in order to possibly understand or quantify the possible cyclic loading, you have to have detailed site investigation. Then to understand the overall ecosystem, the flora and fauna, the ecology of the system, the geomorphological features which are available in and around the study area, you have to have detailed site investigation for offshore. Now in very important thing here, like in addition to go for understanding the soil and subsoil information, which we generally do in case of onshore structure also, what happens when we go for offshore investigation, there are very separate regulatory agencies, authorities are there. The objective of those agencies are to ensure that the flora and fauna of your study area and its vicinity should be maintained or should be disturbed as minimum as possible. Further, you have to ensure at the end, once your project gets over, the ecology of the system should be brought to its original condition. So this is, though it is you can consider it as a part of objective, or you can consider it is equally important than the objective, but it is because of the constraints or guidelines provided by the regulatory agencies. So that is why maintaining the ecology of the system is equally important, in addition to know about the sites, so that you can get an idea about the foundation, you can get idea about loading condition, design parameters, and so on and so forth. Then further, for better preparedness, as I mentioned, like in later stage during construction time, it's almost impossible to change your design parameters or the foundation choice. Secondly, you cannot go for ground improvement. Thirdly, in case of any accident, so once you do proper detailed investigation, you will get some idea like what are the chances at later stage, some kind of accident possibility is there or it is not there. So accordingly, you can prepare the team, you can be prepared at the site once you are going for detailed investigation like geotechnical investigation where you are actually going to drill, or during laying of the foundation, or maybe during the operation part also. So operation, the accident can happen during detailed geotechnical, it can happen during laying of foundation, it can happen during actual exploration purpose where when you are actually exploring the oil or gas at the in situ condition. Then exploring the suitability of construction resources, what are the resources available to you, and depending upon those resources, whether those resources are suitable to provide or to lay the foundation which you are going to design, that decision making will also be helped once you go for detailed site investigation. The next one is to understand the possible geohazard at the site of the interest, whether it is related to geology, whether it is related to whether it is related to tsunami, whether it is related to seismicity, and so on and so forth. So that once you go for detailed investigation like this, all possible geohazards will be identified, and you will also get an understanding like what are the design parameter which will be resembling each of these geohazards, and you will take appropriately the consideration into your design of the foundation. Now, before planning for any kind of detailed investigation, when if you remember, we also told particularly when going for onshore investigation, you have to go for reconnaissance survey, you have to collect experience, you have to collect the reasons of failure if any from the surrounding regions or the other projects which have been constructed in the vicinity of your proposed site. So is the case with your offshore investigation. So before going for any detailed investigation, you have to collect already existing information which may be available in terms of geological map, it may be available in terms of seismological maps like seismic atlas map, it may be available in terms of chart datum, it may be available in terms of the map just I referred from USGS, which gives you an idea about like what will be the depth of overburden or what is the depth of thickness tentatively available at your site of the interest. Once you have those information that you give, that will give you an idea or some confidence which is required to decide what are the methods you have to adopt for particular investigation and what are the challenges you may face when you go for detailed investigation. So with this, those were the objective of site investigation. In today's class, as I mentioned, we will be discussing about geophysical survey. So what are the objectives of geophysical survey in case of offshore investigation? If you remember, in case of onshore investigation, we were interested to find out different stratigraphy, the soil type and strength characteristics of the soil in particularly. But in case of offshore investigation, because the environment is different, so you have some more objectives here. The first one is called as to measure the water depth. If you remember, in onshore there was no such objective, because in offshore there will be water, and beneath the water actually you will be having the sediments, and below the sediment you will be having the rocky stratum. So depending upon what kind of structure you are targeting for, it may be possible it may rest on soil itself or it may go to deeper medium depending upon what kind of structure is there. So in order to the objective lies here is to measure the depth of the water on which you are going for detailed investigation. So you can this is particularly called as bathymetry mapping. You can done it based on echo sounding method, or you can done it using swath bathymetry. Second objective is to measure the sea floor, because sea floor again it came into existence because of different processes which are still happening along the sea floor. So you can have some discontinuous channel, you can have some uniform deposition, and even there can be lateral variation in the sediment deposited in the on the sea floor. In addition to this, you can have possible obstacles which have been deposited, which were not there in actual condition, but have been deposited maybe different processes. So for this you can go for side scan sonar, that is sound navigation and ranging. So based on the vessel you can have this kind of investigation. You put the receivers on both the side and then get an idea about what are the what is the characteristic of the sea floor, and what are the kind and type of obstacle which are available on the sea floor, even the broken vessels which were submerged maybe long back, or maybe some other objectives which but are actually there at the side, so that later on once you go for detailed investigation or exploration purpose, you will not encounter those obstacles to be there at the site of the interest. And the last and the most important thing is to understand sub-bottom stratification. So, in onshore we started exploring from the top itself, but offshore investigation, because the environment on which you are going to lay your foundation, it is actually starting after certain depth of water column. So, certain method which can actually get you an idea about sub-bottom stratification below the sea floor, you can usually go for seismic reflection survey, as we had practiced in onshore structure. So, bathymetry, as I mentioned here, the objective is to determine the water depth at your the point of observation. If you are interested to do survey for larger area, then bathymetry possibly give you an indication of variation in water depth along your study area, or indirectly giving you an indication about sea floor. Then 3D imaging of seabed, because there will be some obstacle also. So, there will be 2D imaging, and if you are doing the survey for a larger area, that will help you in getting a 3D image, how the overall lithology of the topography of the sea floor and possible obstacle is changing along the study area. Third one, to study seabed slope at the location of the interest, that will also possibly indicate you the possible variation or topography, or if some slope is there, then whether there is any chance of discontinuity is there, or whether there is any ridge or any other characteristic which is available there, or maybe sea mound. So, that will also get you may get some idea once you do bathymetry mapping. Then another important objective of bathymetry mapping is to find out features such as faults, scars, volcanoes, etc., which are actually available, but unless you do the test, you will not be able to get those things. So, this is another objective of bathymetry. Now, as I mentioned here, so the broadly, if you say there are three objectives: ones to know about water column, second, once you pass the water column, what is the characteristic of seabed, third, once you go below the seabed, what are the stratification, what are the different layers and characteristics of those layers, and depending upon those layer characteristics, what kind of foundation, what will be the depth of the foundation, what is the mechanism based on which you can actually set up your foundation in situ condition. So, all those will be collectively considered as the broad three objectives of offshore investigation. So, the first one, in echo sounding, what you do, the test usually consists of single beam of echo sounder. What it does, it actually emits a sound pulse from the source, which is generally loaded on a vessel. So, vessel like ships, which are particularly designed for this kind of investigation into the sea. So, those investigation vessels or onshore investigation systems will contain echo sounder, which will emit a particular sound wave. What will happen? This sound wave will travel towards the sea floor. Once it travels the sea floor, either it is getting reflected from the sea floor, or at the location where you are actually emitted the sound wave, if it finds some obstacle, again it will reflect back. So, whether it is sea floor or it is an obstacle, in both the cases sound whatever sound pulse you have generated, it will be reflected back and it will be recorded by the receiver kept at the same vessel. So, depending upon the time required between emitting a sound wave and the time when the same sound, the echo of this sound is getting detected at the receiver, that is going to give you an indication about how much will be the depth of the water at that particular location. So, depending upon the arrival time, depending upon the speed of the sound there in sea water, of course, we all know the speed of the sound in air, but the speed of the sound in sea water will be significantly higher. So, once you know these two parameters, you can get an idea about how much will be the depth of water at your observation point. The speed of the sound I would like to highlight here, particularly in sea water, is in the range of 1450 to 1500 meter per second, which is almost 4 to 4.5 times higher than what is the speed on on ground surface or in air. So, above values may change, the speed of the sound may change depending upon the temperature of the water as well as the containment load which the sea water is containing. So, those two parameters more precisely can affect the speed of sound with which the wave will be travelling and will be reflecting back, and its echo will be recorded at the receiver. Now, there are two systems, just like your any geophysical survey. Two systems are there: active system, which will actually detects the echo, which will actually send an echo and record its, which will actually send a sound pulse and record its echo as obtained after reflection from sea floor or maybe an obstacle in between. On the contrary, you have passive system, which will actually detect the echo as a result of some sound coming out from some other source. So, in passive survey you are actually not emitting some kind of sound wave, but you are actually detecting. So, it is the second part of your active survey, where you are having a receiver, you will be actually detecting the arrival time, which is the source may be something else, but because depending upon the arrival time or because of the characteristics of echo, you are actually understanding the characteristics of the sea floor. Now, this I told about single beam or single impulse. What you do in swath bathymetry, again the objective is to map sea floor and the water depth. So, there what we do, we consider multiple beams of sounds which are actually reflecting at the same time, but covering a larger area. So, some beam will be near to the vessel, some will be again at some inclination to the vessel, and so on and so forth on both the sides of the vessel. So, that is how at the same time you will be able to record more number of echoes as obtaining or as reflecting from a larger distance, the larger distance range with respect to the vessel. So, vessel is there, then there will be some reflection from some location on sea floor adjacent to the vessel. Later on some reflection will be there from some sea floor which is maybe at larger distance with respect to the vessel, and so on and so forth. You are doing it simultaneously. So, at the same time you are able to map or understand the sea floor characteristics for a larger range. So, generally we go for the distance with respect to the vessel equal to twice the width of the water column at the vessel location for consideration. So, 2 times on this side, 2 times on the other side, you can get an idea like what will the overall study area which is to be surveyed at same instances. So, the objective remains same, you are generating a sound pulse, you are actually detecting its echo. In single beam you are actually measuring the water depth at the observation point. Once you go for multi beam, you are actually doing the same thing, but over a larger area, and that too simultaneously. So, this way swath bathymetry gives you a continuous profiling of sea floor and is very helpful if you are going for surveying a very larger area. So, you can again when you are going for significantly larger area, you can divide the entire area into number of grids, do this kinds of surveying along each grid line. You divide the entire area into small grids. Along the grid lines you can do no number of tests that will help you in understanding overall the characteristic of the sea floor or maybe possible obstacle if any. Now, we know depending upon the frequency characteristics, different sources can be used to explore different water columns. So, to give you an idea, the high frequency sources which are particularly capable of generating 100 to 450, this should be 450 kilohertz, that kind of higher frequencies you can take into account, particularly when you are understanding, when you are interested to understand sometime like water depth of 300 meter or so. Same way medium frequency you can go from 30 to 100 kilohertz when you are interested to go for investigation in water depth of up to 3600 meter. Third one, when you are interested to go for deeper water columns or deep oceans as given here like greater than 6000 meter, you can particularly use a source which is capable of generating low frequency, that is 12 to 18 kilohertz. So, based on this the choice of the source can be made, and further in order to understand the choice, so you have to get some idea based on already existing report like what is the depth of water in that particular location. You can choose a particular source, or maybe you can go for echo sounding test, get an idea about get a rough idea about what will be the range of water depth at your site of interest, and accordingly you can choose the kind of source which will be required for bathymetry. At each location, again as we mentioned, like you are the objective is to get you a 3D image. So, it is also very important to precisely determine the position of the vessel, where actually it is determining the water depth or sea floor mapping. So, that can be done using the satellite data and based on differential global positioning system, that is DGPS. It is desired that like the position should be determined as accurately as up to 0.1 meter. Now, two important information which I would like to highlight here. We know like there is vessel, we know there is sea floor, but in between the two there can be number of aquatic lives which are continuously moving here and there. So, what are the chances like your results can get affected? To give you an example for fishes may be available between the source of the sound as well as the seabed. However, in comparison to the sea floor or seabed and other obstacles which are available on the seabed, we can see like the fishes which contain almost 80% of water cannot contribute significantly or cannot contribute equal nature of echo as contributed by the sea floor. So, that is why the chances like the findings of echo sounding towards water depth and sea floor getting affected by the presence of fishes and other marine organism is almost nil. Second thing, this is also important, like depending upon the characteristics of the seabed, while a hard seabed gives you a very clear indication about a reflection peak, a softer medium usually provide you a weaker reflection. So, it will be difficult when you are having softer medium to get exact peak, and since exact peak is a challenging task, again that will lead to uncertainty with respect to water depth determination. Now, here we are going to see some one or two numerical examples which particularly work on your echo sounding method. As we mentioned, like there is some sounding vessel, it is generating some sound impulse which is getting reflected and coming on to the surface. More precisely, I can say here, like you can have a source, receiver. So, you are actually imparting some kind of sound here. This is sea floor or seabed. So, once after reflection, it will again reflect and getting detected at the same vessel. So, you know if this is the water depth D, so wave will be travelling at depth D to reach sea floor, again it will be reflecting back. So, it will become D plus D, another D which is, so this is going down, this is going up. So, total distance will be 2D, time if you can calculate delta T, that will give you an idea about how much will be the depth of this if you know the velocity here. So, this example says an ocean vessel, you can consider maybe some sonar system vessel, is using a sonar for detecting ocean bottom or water depth. The speed of sound that travels through vessel is 1450 meter per second. The bottom is 1630 meter from the surface, that is sea floor. Calculate the time taken by the wave to get reflected back to the surface. So, you are interested to find out after how much time of since you emit the sound wave, it will be reflected back or you will detect an echo. So, you are interested to find out the value of time here. You know the value of V of sound, that is 1450 meter per second. You know the value of D, that is the distance between the vessel as well as your seabed, as 1630 meter. So, 2D, because one side it will be travelling down, second side it will be coming up, it will be 2 times 1630, that is 3260 meter. So, how much will be the time? As we know, like time will be equals to distance divided by the speed, that is 3260 divided by 1450. So, after 2.25 seconds, you are actually receiving a sound impulse from the source. Same way you can go for another example. It is like a ship sends a sound wave to the bottom of the sea and received an echo after 0.3 second. So, you have a ship which is actually containing a source, impulse is sent and echo is received after time delta t equals to 0.3 second. Okay, consider the sound. So, Vs is given as 1500 meter per second. Okay, calculate the depth of the water if the okay, in addition one more information is given, like this is your vessel which is containing your source and this is your sea. So, what it is telling, somewhere here is your source which is actually creating an impulse. So, it is telling this source is there at 2.3 meter. So, the distance between the sea water surface as well as the source, it is 2.3. Now, you are interested to determine how much will be the value of water depth. So, based on this you can get an idea about 2D, that is the distance travelled by the wave 2 times, that will be equal to how much, Vs times delta t, that is 1500 multiplied by 0.3, that is 450 meter. Now, the depth below the vessel or below the source will be 450 divided by 2, that is 225 meter. So, this is 225 meter from here to seabed. This is called as seabed. So, what will be the total depth of water? (225), which is up till the source, plus 2.3. So, that will become like 227.3 meters. So, this is the total depth of water at your study area, where you have actually used the vessel such that the source is 2.3 meter below the sea water level. So, this is about that is how you can get an idea about sea water depth as well as the sea floor characteristics. Then about sea floor, like the different layers which are available beneath the seabed, that is called as subsea bed profiling. So, this can be done using traditional seismic reflection and refraction survey, but unlike your traditional survey where you can put actually the sensor as well as receiver on the surface, here actually water is there above the seabed. So, actually you can go, the traditional one is consisting of towed vehicle, like you will be having a source followed by a number of receiver or an array of receiver. So, while the source generates a seismic impulse, the receiver will detect this seismic impulse. So, depending upon the time of arrival of reflected or refracted wave from different interfaces, that will get you an idea about the characteristics of different interfaces or different medium which is available beneath the sea bed. So, you know the water depth, you know the the seafloor quality, then based on subseabed profiling you get an idea about the different layers which are available beneath the surface. I am not going into detail because seismic reflection we have already discussed. One important thing to be highlighted here is, in case of this towed vehicle, this is generally available few meters beneath the sea level. So, that means below the top surface or mean sea level, it is somewhere 2 to 3 meter below the ground below the sea level or water surface, and then a 2D array, I mean it is used generally to go for high resolution survey. Most optimal frequency, now again you know, like depending upon the frequency you can play with the I mean you can get confidence about the depth of the penetration, but on the contrary, depending upon the strength of that particular source which is creating a particular frequency wave, your quality of the signal will get altered. So, most optimal frequency should be chosen such that the optimal depth of the penetration as well as sufficient quality of your data to be interpreted should be received. That will be always there as you go for onshore or you go for offshore based seismic reflection survey. So, generally the sources which are consisting of boomers, sparkers or air guns, which can target even up to penetration depth of 100 to 200 meter with low to good resolution are often available. So, depending upon the depth of exploration, one can go for any of these kind of sources. Certain agencies are there because these kind of surveys cannot be run on small scale, lot of finance also involved. So, the kind of vessel, the kind of source, the kind of receivers to be used should be chosen based on the experience of the expert. Now, I told this profiling particularly whenever we are going for water depth determination, whenever we are going for sub-bed profiling, we are often going for survey which are either on you are doing it from the sea water level or maybe certain meter below the sea water table. Nowadays, in particularly in last 1 decades, you are having now the autonomous underwater vehicles. So, these can actually help in determining water depth, sea floor characteristic as well as sub-level stratification by doing the survey even at the sea floor bed, at the sea bed itself. So, towed vehicles are usually controlled by means of umbilical cords connected to its main vessel. So, you are doing the survey, but every time you are transferring the data. However, AUV, that is autonomous underwater vehicle, consists of performing same test for water depth determination, for seabed mapping as well as for sub-bottom profiling in its in situ condition. It can store data in situ, and once the test is done you can bring it onto the surface, transfer the data, or by other ways you can actually keep on transferring the data to the main unit which is kept at the surface. So, both ways it is possible. You finish the test, bring it onto the surface, transfer the data, or continuous shifting of data from the AUV to the surface assembly is also possible. So, with this I will stop. I hope today's class has given you some insight information like how we go for geophysical investigation, particularly onshore environment, offshore environment, what are the depth of interest, what are the frequencies to be looked into once you are selecting a particular source. Secondly, only the frequency of interest should not be the major concern, but also the quality of the data, because that will also help you in gaining more and more confidence as far as the interpretation of the results is concerned. So, thank you.